Hi, this is Mr. Max with Sankofa Mathematics. Now, this is my third video on the trigonometry series, examination type questions that we have been doing through the course of this series. So, the first question here, you have a diagram here on the right, and it shows a semicircle with center O, and the radius is 6 centimeters, and the radius of OC is perpendicular to the diameter of AB. That means makes 90 degrees. Therefore, this is a right angle triangle here, the triangle BOC. And the point D lies on AB, and DC is an arc with the circle of a circle with center B. Very important, this one. Right, first part, you're supposed to calculate the length of the arc, and then for part B, you're supposed to find the area of region P divided by the area of region Q, and then you give your answer to 3 significant figures. Now, it's very important that you remember how to calculate the area of sectors and also how to find the part, like an arc length, okay? So I'm using the formulas that are normally associated with radians. So I hope you can just quickly go back and you will see quite a lot of videos that I have done when you can find the area of sectors using those two formula. Right, so this distance is going to be the same as OB because you see it's a radius. OB is a radius, OC is a radius of the same semicircle. That means these two radii will be the same. And also, once you have this right angle triangle here, you can actually calculate also the distance CB. That distance CB is actually now a radius of a circle of center B from B to C and B to D. So whatever this particular other circle is that goes around like that, for this particular sector, the radius will be 6 times square root of 2 or just the square root of 72. Right. This angle here will be 45 degrees or pi upon 4 radians because remember this is an isosceles right angle triangle and I'm going to use pi upon 4. Right, so here we have this sector. So we are going to find first this arc length. So let me bring in the calculations that I have. So that is 6 root 2. This is also 6 root 2. And this angle here I said is 45 degrees or pi upon 4 radians. So I can definitely calculate now the arc length, and to find the arc length you multiply the angle with the radius, and I hope that you still remember this formula. Okay, so that brings you to about 6.6 centimeters if you have to do that question. So part B, you're supposed to find the value of the area of region P. That means this little region here. And then you are supposed to divide that by the area of region Q, which is this little small one here. And then you're supposed to give your answer to 3 significant figures. So I'm going to use some steps, about 6 or so steps, so that I can just separate my work so you can see. So step 1, I am going to find the area of the whole sector here. So the area of the sector, remember the formula is half r square theta. Okay. And if you punch in, so this area of the sector here is 9 pi square centimeters. Then step 2, I'm going to calculate the area of triangle BCD. Remember this right angle triangle here. The reason why I want to do that is if I have the whole sector and then I have the triangle, if I subtract the 2, I will get this little Q here. So this is the right angle triangle, so just half base times height, which gives me 18 square centimeters. Step 3, now I'm going to find Q by taking what I got in step 1, so take away what I got in step 2. So that brings me to 9 pi minus 18. I'm going to leave my answer like that. I'm only going to do the rounding towards the end. Right, so step 4, what I'm going to do, I'm going to calculate a quarter circle. This is now this one here, CAO, this one here, the whole of this. It's a quarter of a circle. The formula to calculate the area of a circle is pi r squared, but it's just 1/4. So punch in, you get 1/4 times pi times the radius. That gives me 9 pi square centimeters. So that's the area of ACO. And now, step 5, I'm going to take, in order for me to find the area of P, I'm going to take what I got in step 4, that's the area of this quarter circle, and I'm going to subtract it by that little Q there, which I already have in step 3. Okay, so once I do that, I get to about 18 square centimeters. Now I'm very close to the end. So for step 6, which is my last step, now you can actually put region P, which is 18, important region Q, which is that 9 pi minus 18, and you get about 1.7519 and so on. So to 3 significant figures, the area of that region divided by other region, that ratio there is 1.75. So there are quite a number of steps. There are many other ways you can do this. You can use cosine rules and stuff like that. But I believe this is also one of the better methods. Question 2. Again, pause the video. Try to attempt to do this question on your own. It says that the function f is such that f of x is equal to a plus b cosine x for x between 0 and 2 pi radians, or 0 to 360 degrees. So remember this b that you see here, that's the amplitude. And then it is also given that f of pi upon 3 is equal to 5 and f of pi is equal to 11. So that means we're going to have to establish two equations because we're supposed to find the constants a and b. So once we create the two equations, we're going to then solve them simultaneously. And then you are also given a hint that says that this pi upon 3, this angle here is in the first quadrant, okay, and also pi cos pi upon 3. But anyway, I will not go to the special angles. I'm just going to solve this by substituting pi upon 3 into x. You punch this on your calculator, but here's the thing, remember, your calculator, as because we're dealing with radians, it should be in radian mode, okay? So I'm going to have here a half if I press pi upon 3, cosine pi upon 3. And now obviously this can be simplified to 2a plus b is equal to 10, or you can leave it as a plus b upon 2 equals to 5. But in any case, that is my first equation. My second equation, I'm going to use the f of pi, which equals to 11. And then where I have an x, I replace that with pi. And on your calculator, when you press cosine of 180 degrees or cosine of pi, you're going to get that it should give you -1. Remember, I said my calculator is now in radian mode because the domain was given in radians. Okay, and then the second equation, therefore, I have a minus b equals to 11. So now you can solve these two equations. This become ordinary work that should not be that difficult to complete. Okay, so the way you can solve it is completing the square or by eliminating, like I did here. I'm using the method of elimination by eliminating the b's. By adding, I get that a will equal to 7. Now once I have that a, I can substitute it in either one of my equation. I chose equation 1 or equation 2. In equation 2, it's going to give you 7 minus b equals to 11, and then b will be equal to -4. So therefore the value of a is 7 and the value of b is -4. Right, this is the third question. Again, have a look at this question. So the diagram shows triangle ABC, and AB is equal to 5, AC equals to 4, BC equals to 3. This should trigger something about trigonometry when you have a 5, 4, 3 triangle. This is a Pythagorean triplets. Okay, I still hope you remember those. Then there are 3 circles with centers A, B, and C with radii 3, 4, 3 centimeters, F and G. The radius is 3 centimeters, 2 centimeters, and 1 centimeters respectively. F and G lying on AB, AC, and BC respectively, as you can see. Find the area of the shaded region EFG. Okay, so the way I'm going to look at this, because I spoke about that 5, 4, 3 triangle, that is a right angle triangle. Okay, so if I just put those values in there, and how do you show that something is a right angle triangle? Well, you take the longer side squared, see it equals to the sum of the squares of the two shorter sides. In this case is the case, so I'm dealing with a right angle triangle. Why is this important information for me? Because now I can actually find those missing angles A and B. Because in order for me to find the area of this sector AEF, for example, I need to know what angle A is. In order to find this area of sector BEG, I need to know what angle B is. Now angle C here is 90 degrees or pi upon 2, so that is going to be calculated then. Alright, so I will take the area of the whole triangle, so I'll find the area of the triangle, then I'll subtract the areas of these other small sectors, and that will give me the shaded part. Okay, so if that angle is theta, this one here has to be pi upon 2 minus theta. So if that angle is something, then this one here should be 90 degrees minus whatever that is. Okay, so let me just try to find, according to my label, what that angle A would be. So I'm using the tangent ratio, but you're going to go ahead and use any ratio. Okay, so it's about 0.6435 radians, that angle there. And obviously then angle B, this one here, will be pi upon 2 minus that, which gives me about 0.9273 radians. Okay, so now I have these two angles and I can actually plot them onto my diagram, and then I can find the areas of the sectors, the area of the big triangle, and I do exactly like I did in the previous question, step by step, and then I subtract. Okay, so let's bring the triangle back with the angles now included. And the diagram is here. We are looking for the shaded part. So step 1, area of the triangle. Well, it's just half base times height, which is 6 square centimeters. Remember, the perpendicular sides where they sort of intersect. One will be the base, one will be the height. It doesn't really matter. Then I have to find area of sector AEF. So it's this one here with that angle of 0.6435 radians. That gives me about 2.8958 square centimeters. Step 3, I'm going to find the sector for BEG. BEG, this one here, with a radius of 2. Okay, and then that angle there is 0.9273 radians. So I get about 1.855 square centimeter. Then the sector CFG. Obviously, this angle here is 90 degrees, as you can see on the diagram. So 90 degrees is pi upon 2, and the radius is 1. That gives me that. So now I have got the areas for all the three sectors. I have the area for the triangle, so I will just have to find the area of the triangle, subtract from the sum of the areas of the sectors, as I have laid it out here step by step. So that's going to be equal to about 0.464. I know there's a lot of things that look like I was going a bit fast, but remember, you have the advantage of pausing the video and then checking up to follow what I'm doing.